The week before last week, we were talking about discharge lamps, you remember? And the discharge lamps, we talked about different discharge lamps and how we use them and how the application, their construction, their advantages and disadvantages. So today we are going to talk about troubleshooting and maintenance and faults that are commonly found in discharge lamps, so that we can finish the topic about discharge lamps. So this discharge lamp troubleshooting and maintenance. So we start with the high intensity discharge lamps. Remember we talked about the high intensity discharge lamps. They are the commonly used lamps that we have. The broad term used for to describe any lighting system using a gaseous discharge, that is the arc lamp, in which the gas-filled arc tube operates at several times normal atmospheric pressure compared to the near vacuum conditions in fluorescent lamps. So the various types of HID lamps are categorized and named by the type of gas contained within the arc tube. The electric arc produced between the two main electrodes of the HID, that is the high intensity discharge lamp, is much more like a runaway shoot current, which can be sustained indefinitely. So sufficient voltage is present. The gas within the arc tube are ionized to where they will conduct the arc current. So the arc formation is not an immediate process. It can take several seconds for the arc to be established. So and several minutes until full light output can be reached. So the HID lamps are negative independent devices. This means that unless controlled, the current would continue to increase, causing the lamp to fail almost instantly after starting. So those are some of the problems that they encounter. This means that unless controlled, the current would continue to increase, causing the lamp to fall almost instantly after starting. So for this reason, a ballast, which is a current limiting device, must be used with, yes, Salad.
No.
Salad. I hope you're getting us. So we are talking about maintaining of the high intensity discharge lamps. Salad. Seems you have problems today. Okay. If you can hear us, just mute the mic. Okay. Okay, let's proceed. So the ionization voltage of all the HID lamps increases greatly when the lamp is hot. So if power in the lamp is interrupted, the lamp must be allowed to cool for some time, usually several minutes, before the arc can be reestablished and normal operation resumed. So for this reason, some ballasts are available with a tap to operate a standby or auxiliary incandescent lamp through an appropriate interface. So those are some of the corrective measures. So the 120 volts lead on dual, tri and multiple voltage ballast can be used as a tap for standby lighting when the ballast is supplied by a higher line of voltage. For some ballast lamp combinations, an instant restrike starter is available. So suggestions for the HID fixture maintenance. So how do we maintain these high intensity discharge lamps? So for proper maintenance of the lighting system, it is essential to maintain levels of illumination necessary for productivity, meaning mechanizing that is visual comfort, safety, and security. So if an individual component fails and is allowed to remain in lighting system, costly damage of the other components can result. So this is what we say, that, for example, if we are, for instance, if we talk about the the fluorescent tubes. So if maybe a choke is spoiled, or one part of the lamp is spoiled, we need to replace it immediately, so that we can be able to do away with the problem or to correct the problem. That is called maintenance. But if we leave that problem to persist for some time or for quite a long time, it means it will damage other parts and it will cause the destruction for the whole lamp. So the major repairs can often be avoided by simple maintenance procedure and timely attention to small problems such as replacing burnout lamps. So preventing a problem from occurring is more desirable and economical than fixing it later. That is obvious that preventing this thing from going on, or preventing the problem from recurring, is far much important than fixing it later or buying a new thing, because it's more costly. Sorry. So by using the following maintenance strategies, the ballast will have a longer and more trouble-free life. There are many lighting maintenance contractors and electrical contractors who can economically perform a scheduled maintenance program. So we have the group relamping. The lamps should be replaced as a group at a scheduled periodic intervals based on the rated life, and then a minimum acceptable lighting levels are systems operation cost. The lamp supplier has additional information available regarding to the lamp maintenance procedures. Then the cleaning. What about the cleaning? The lamp reflectors and lens should be cleaned periodically. Be sure to follow the recommendations of the fixture and or the reflector of the manufacturer. An inspection. What happens in the inspection? That is, in addition to obtain normal ballast life, the maximum efficacy for the high intensity discharge lamp lighting installation fixtures should be periodically inspected for, number one, the lamps cycling and on and off. Another one is the heavy lamp deterioration, discoloration. Another one is the dim lamps. It should be inspected for the dim lamps. Another one is the for slow starting lamps. You inspect and tend to know why is it, or how does it affect. Another one is the inappropriate lamp, and then dust and dirt. So the significance and the correction of these conditions can vary with the type of lamp and ballast used. So these are covered in greater detail in this guide. So lamps should be checked to be sure the proper lamp type is being used. So according to the information of the label of the installed ballast, many lamp types currently offered, such as metal halide and high pressure sodium lamps, are physically interchangeable but not electrically interchangeable. So the line voltage should be checked at the fixture and compared with the ballast rating to be sure it is within the prescribed limits. So a high pressure sodium lamp cycling on or off usually indicates the lamp has reached the end of the normal life. So the lamp cycling on and off with an east or port ballast or other ballast which contains thermal protection. Another thing is safety. The ballast capacitor and starter replacement, as well as lighting maintenance, presents the possibility of exposure to potential hazardous voltages and should be performed only by qualified persons, meaning the person who does the maintenance or the changing of the spoiled parts has to be experienced and a skilled person who has an experience of those fixtures. So all installation, inspection, and maintenance should be performed only with the entire circuit power to the fixture or equipment turned off. So all ballast components and fixtures must be installed and operated in compliance with the National Electrical Code requirements of underwriters, that is the laboratories for the laboratories and all applicable codes and regulations. So this includes, but is not limited to, proper grounding of the ballast components and fixtures, as well as prescribed branch of the total protection. So we are, remember, we are doing troubleshooting and maintenance. So in maintaining, you want to make sure that this lamp does not come down totally. That is, and troubleshooting now, in case there is some problem or some sign of a problem, you troubleshoot, meaning to check where the problem is. So this concise guide, that is troubleshooting, provides a logical sequence of procedure for troubleshooting and correcting the most commonly problems in typical HID lamp system. So there are many specialized ballast lamps, fixtures, and lighting controls which are not specifically addressed. So shooter should always check for the special condition which might exist in an installation or an exception of the rules or the potential safety hazard. So protect the ballast. So a ballast, like any electrical device, generates heat. To ensure maximum ballast life, it is imperative that operating temperatures be kept low, burned out or falling lamps, or high temperatures or in or around the fixture can cause the ballast to overheat. So resulting in premature failure. So for more information regarding heat effect on ballast life, in addition to recommending life on performance, consult Universal Lighting Technologies. So troubleshooting and maintenance. You remember that the flowcharts that we have been using for troubleshooting and maintenance. This is again another one that is used for troubleshooting and maintenance. Now, like for example, chart 1, that is lamp is inoperative, does not operate well. So is there power on the fixture? That one you ask yourself. We are now troubleshooting. We want to know where the problem is. That is for the HID lighting system. You ask yourself, is there power in the fixture? If the answer is no, then check the external cause and check the normal operation. If the answer is yes, then at inline fuses on other devices such as photocells, automatic shut-off status, or sensors at fault or causing the problem. If the answer is yes, then replace the faulty components or reset shut-off devices and check for normal operation. If the answer is no, then you ask yourself, are abnormal lamp or socket conditions at fault? Then if the answer is yes, then correct the abnormal conditions and then replace the components as needed and check for the normal operation. If the answer is no, you continue and ask yourself, has the lamp failed under normal conditions? If the answer is yes, then replace the failed lamp and check for normal operations. And if the answer is no, then ask yourself again, are the lamp or ballast or capacitor or starter, that is if applicable, compatible? Are they compatible? If the answer is no, then replace the incorrect component or components and check for normal operation. And if the answer is yes, then as the ballast and starter mounted too far from the lamp? If the answer is yes, then correct the proper distance of the or install the long distance starter. If the answer is no, is the fixture wired correctly? Then you ask yourself, correct and check the normal. If the answer is no, you correct and check the normal operation. But if the answer is yes, then are the voltage and the tap connections correct? If the answer is no, then correct the supply voltage and within the specified tolerance or correct tap connection. If the answer is yes, then is the capacitor faulty? If the answer is yes, then replace the faulty capacitor and check for normal operation. If the answer is no, then are the ballast and starter operating properly? If the answer is no, then replace the faulty component and check for the normal operation. So that is a flowchart of troubleshooting and maintenance of the HID lighting system. That is chart 2. That is for a short life lamp. uh, for a short life, for very short life lamp. Now, is the lamp compatible with the system? If the answer is no, then replace the lamp correct lamp. And then if the answer is yes, is the lamp operating in correct position? Then if the answer is no, then replace the lamp with an appropriate lamp for the operation position or change the operating position. But if the answer is yes, you proceed and say, is the outlet is the outer bulb cracked? If the answer is yes, then replace the lamp and check for normal operation. But if the answer is no, you proceed and ask yourself, are there signs of lamp over wattage or over current operation? If the answer is no, then replace the lamp and check for normal operation. If the answer is yes, then are the components compatible? If the answer is no, then replace the incorrect components and check for normal operation. If the answer is yes, then ask yourself, are the line voltages and tap connections correct? If the answer is no, then correct the supply voltage to within the specified tolerance or current tap connection. If the answer is yes, and then is the capacitor shorted? That is, you ask yourself, is the capacitor shorted? If the answer is yes, then replace the faulty capacitor and check for normal operation. But if the answer is no, then ask yourself, is the ballast operating properly? If the answer is no, then replace the faulty ballast and check for normal operations. If the answer is no, then are operating periods shorter than rated? And then if the answer is yes, then recess hours after start and adjust estimate of the lamp accordingly. Now for low lamp light output, now that is the flowchart. I think that one you'll be able to go through it at your own time. This one is the life cycle on and off. The ones that have a life cycling of being on and off, and then the appendix is there for the lighting outputs. Lighting performance is there, the start time and the end time, then the compatibility, and then the appendix. Okay. So now checking the capacitor, disconnect the capacitor, discharge the capacitor, use an ohmmeter. On the highest scale, if the meter reads low resistance initially and increases the capacitor, is good. If the meter reads low change, it is shorted and must be replaced. Then if the meter reads high resistance initially and does not change, it is open and must be replaced. So be sure to check for the correct abnormal conditions such as high ambient temperature, incompatibility, etc., which may have caused the or contributed to the capacitor failure or caused the capacitor's internal protector to activate. So the faulty capacitor. For the faulty capacitor, so if it is shorted, the ballast type, then it has high resistance, then what the result is the high line current, that is may open circuit breaker or burn out the primary coil of the ballast. So the capacitor's initial protector may function, resulting to open capacitor, a normal power factor operation. And then if it is shortened again for the CWA metal halide mercury, then what happens? That is the high lamp current. That is the result. Then may open circuit or burn off the primary ballast or may shorten the lamp life. If the capacitor condition is also shortened for the CWA HPS, then the result may be that there is low. The result may be that there is low current, low light output, or no ballast damage. So that is a summary. If the capacitor is open, that is for high resistance, that we have the single capacitor, you will be able to go through them as being part of that. So I want to bring another slide. So these are some of the problems that we will experience when using these lamps. These are some of the challenges that will be experienced. So when you see this, you need to know what to do or what happens. Okay. So, for example, if a fault like now, a lamp will not start. We want to troubleshoot, and remember we are doing the discharge lamps, and we are troubleshooting and maintaining, and we are identifying faults. So we have a lamp that is not starting, meaning the light does not start. So what do we do to it? And then the possible cause of the problem may be number one, maybe no power on the ballast. Then what do you do? The corrective action is to check the fuses and other causes of power outages. Maybe the fuse is off, so that is why the lamp is not starting. Another one is no normal end of lamp life. Labda maybe the lamp life has ended. So what do you do? Then often the simplest procedure is to test the lamp in an adjacent fixture which is known to be operating properly and then replace as necessary. It should be kept in mind that a series ballast will occasionally extinguish the adjacent lamp if one is removed. Another one is number three, that is the lamp loose in socket. If the lamp is loose in the socket, now inspect the lamp to see if there is any indication of arcing at center contact button. So that is the tighten lamp to seat it properly. So if base is distorted and will not sit properly in the socket, that is a problem that can be there. So another one is optional to other sensing, that is the optical and other sensing devices in cooperative. If they are not in cooperative, what do? You replace the sensing device, that is by checking this by covering sensing device or blocking out light while power is applied to the fixture, so that you can see if the sensing device is on. That is now, so remember we are still on when this light will not start. We want to know why the light will not start. So maybe another possible cause is the voltage at fixture too low. When the voltage is too low, so the measure of light voltage as at input or ballast, that is for most types of ballast, measured light voltage should be within 10% of the label rating. So with many types of distribution system, increased loading or demand increases available voltage at the ballast primary. Therefore, ideally, a check should be made at the full load. If tapped ballast match ballast tap connection to supply voltage measured at ballast increases supply voltage, it's feasible, then verify that the lamp to remote ballast distance is acceptable. And then incompatible ballasting. Now, maybe that is a cause. Another one is an incompatible ballasting. Then what you need to do is to correct the ballasting is essential for a dependable, the HID, that is the high intensity lamps. And then discharge lamp, and then operation, and any HD lamp will operate erratically or fail to start an incorrect ballast. So those are some of the causes and the things that can be done. Maybe you realize that we have defective shortened ballast. So what do you do? A shortened ballast will generally cause the seals at the end of the arc tube to rupture with an indicative blackening in the seal ring area. So shortened condition may be due to shortened capacitors, shortened leads, or shortened winding. Replace components as required. Then another one is the improper lamp operating, that is, the operating position should agree with the lamp specifications, and the lamp can be operated based up vertical to and including the horizontal and the BD and can be operated, that is the ballast just lamp can be operated based down. So another cause can be the lamp has been operating, that is cooled down the insufficient hot restrike. So when the HD lamps are operating and the supply voltage is cut off, interrupted, that is the lamp will require a period of time to cool and re-establish optimum starting condition. So bare mercury and metal halide lamps require from 4 to 8 minutes to cool down. So another problem is maybe there's a high resistance voltage, that is the metal halide only. So what happens here, and then the condition is peculiar to the metal halide lamp, so it does not occur with mercury. So if the supply voltage of the metal halide lamp is interrupted during the warm-up period, the subsequent strike voltage may be higher that require for a lamp which has been allowed to stabilize. Sometimes you will get that there is improper ballast or for lamp operating condition, the improper ballast. So what do we do? Environmental conditions such as extreme temperatures, high humidity, and other factors affect ballast operation. So check lamp environment operating conditions against published performance. And then end of ballast life. So if there's end of ballast life, then the appearance or the condition of the ballast may give a clue to whether it is good or not. So if it is charred, it may have been subjected to sustained excessive heat. Another problem can be that there is a defective igniter. Maybe the igniter is defective. So ensure that the lamp is good. That is a corrective measure that can be done. That is, ensure that the lamp is good, disconnect the igniter and install a specified test lamp. So if the test lamp lights, then the ballast is good, but the igniter is not. So replace the igniter. If the test lamp does not light, then the ballast has most likely reached its end life. Another one is the mismatch igniter. So verify that the ballast and the igniter are matched according to the specification or replace if necessary. Another problem that can occur, the lamp defects. Maybe the lamp has some defect. What can you do? Maybe the common defects that require the lamp to be replaced include the arc tube task, the open wells, maybe the probe or the cathode electrolysis. And then we have the diode or switch shorted, the quartz deverification around the rod, sodium leak, and then the open diode. Another problem is the lamp life is reduced. And remember, the first problem was the lamp does not want to start. It does not start. So what about the problem of the lamp life is reduced? So if that is the problem, then the possible causes will be the lamp physically damaged. So if the lamp is physically damaged, then investigate the possibility of the outer bulb damage from handling or transportation that may have cracked the glass. So if air enters the outer bulb, the arc tube may continue to burn for like 100 hours before the failure. So check to see if the bulb is broken when the glass meets the base due to the twisting lamp too firmly to the socket or to the sourcing of glass. Another one is a wrong ballast. Then make sure that the ballast label agrees with the line voltage and the installed lamp. Then we have the lamp operating with incorrect position. So either change the positioning of the fixture or replace the lamp with one suitable for that position. Faulty capacitor, then to check a capacitor, disconnect and discharge it, and then use a ohmmeter set to the highest scale. Then check for faults. If the meter reads low resistance initially and increases capacitor is good. Then if the meter reads high resistance initially and remains the same, so the capacitor is shortened and should be high resistance initially and remains the same, the capacitor is open and should be replaced. So another problem is the lamp flickers or cycles on and off. What does it mean? Like I want to use an example of the common lamp that you know, like the fluorescent lamp. Sometimes it flickers. When we say flickers, meaning it comes on and off, on and off, on and off. So sometimes you may ask, what is the problem? So these are the possible causes of that problem. Then maybe there is a wrong ballast. So when the mercury lamp, a proper ballasting can cause flickering, that is improper ballasting, can cause flickering or erratic operation. With metal halide lamps, the effect is generally not noticed in the startup period when the lamp ignites, starts to warm up, and then extinguishes the cycling. So these may be caused by improper voltage current relationship delivered by the ballast. So under certain conditions, the new lamps may cycle, that is usually after 3 tries to start at 30 to 60-second interval lamps that will stabilize the operation and operate normally. Another thing is the high lamp operating, that is the voltage of low output circuit. Another one is the variable voltage. So high motor loads or welding appliances on the line can cause flickering, meaning that is the high variable voltage. When they have a lot of motors, it can cause flickering. So the HPS is cycler, as the high pressure sodium lamp is burned for more periods, the time its operating voltage tends to increase when the point is reached. So the lamp will enroll cycling and off characteristics. This is a normal end. This is a normal end of the lamp life. So another problem is you realize that the lamp starts slowly, that is the arc does not strike when switched, is when the switch is turned on. What are the possible problems? The possible problem is the head starter, the hard starter. That is, the hard starter is a lamp which will not start rapidly. It may glow for extended periods of time, destroying cathodes and it should be replaced after checking voltage or ballast. And then question 5 was problem 5, that is the fuse blows or circuit breaker open on a lamp start. When the lamp starts, the circuit breaker open. Okay. So another problem is the fuse blows when the circuit breaker opens, that is lamp start. So that is the problem can be the overloaded circuit, that is rewire and accommodate starting current of the lamp. And then there can be a higher monetary transient current. It can be caused by the reactor of the auto transformer ballast, which draws high initial currents. Now use current protective devices incorporating the J equipment. Another one is the lamp light output is low. The lamp light output is low. So when the lamp light output is low, what happens? Normal light output, that is the depreciation throughout the life. Then we have referred to the maintenance characteristics lamp of the technical publications operating, comparing the light output versus the burn time. And then we have the incorrect voltage. When the voltage is incorrect, we have incorrect voltage. Refers to the maintenance or characteristics of the lamp in technical publications, comparing light output versus the burning time. So we also have that and other things. So the arc tube becomes blackened. The arc tube becomes blackened. What is the problem? Maybe there is an overwattage or operation, improper ballasting. So what do? You check the possibility of that the lamp is operated on the ballast design for higher wattage lamp, and then overwattage operation can cause premature blackening, and then check the ballast level against the lamp specification, then check the voltage and ballast, check for possibility of current or voltage surge. Another thing is the reflector problem. That is, the reflector design may focus a radiant energy directly to the arc. That is the correction action. Another one is the difference in lamps colors. So the possible cause is normal maintenance. That is, in addition to normal decrease in the decrease in the light output or brightness, then shift can occur as lamps and lamp edge support now the replacement of the failures with new lamps, which may show very noticeable difference in the colors. Another one is when they have different colors, that is, maybe there is a wrong lamp color. Check the etching of the lamp, which appears different, to see if they are actually the same color, then replace with the correct lamp. Sometimes there's a range of manufacturing tolerance. Then sometimes there's a variations in luminaries. Maybe there are several luminaries in the market. Then you need to change the color. Then variation in the environment. Then the faulty capacitor. And then we have symptoms of lighting system problems. What are the symptoms of the lighting system problems? Is that all the discharge lighting system offer visual and okay, let me do away. Then we have the lamp troubleshooting. How do I troubleshoot a fluorescent lamp? Fluorescent lamp, when energized, a rapid start lamp circuit, that is a low voltage transformer in the ballast, provides cathode heating. So at the same time, you are applying a higher voltage called the open circuit voltage across the lamp. So this voltage begins arcing condition in the lamp. It begins the arcing condition in the lamp, taking both voltage measurements as a good indication for proper ballast operation. So show a figure in the left. I'm going to show you the figure shows how to make voltage measurements on two lamp series type and rabbit start magnetic. Okay. So we are still on the fluorescent and how we are going to check the problems. So the condition result from any one of the following, that is improper contact of the holder, broken holder, open contact in the base pin, broken base pin, open cathode, shortened light in the base, corrosion of foreign materials on the base pins or holder contact, defective ballast or improper wiring. So heavy premature and darkening, that is and end darkening, that is usually at only one end. So it is a good indication that one cathode is not properly heated and therefore the heater circuit is incomplete. So in this, the same as gray or brownish heads that occur about two in one. So from the lamp's base, each band on the near side of the size nearer to the base being sharper. So the latter symptom occur when the lamp's cathode coating wears out. So the cathode coating also can wear out and then make it incomplete or incomplete the circuit. Okay. If the spacing is too tight, then the weight of the lamp will ride the face of the base instead of pins occasionally. No, a pin will slide behind of it to its holder. So when installing lamps with exposing pin pins, make sure that the positioning guide that is on the metal lamp is opposite the entrance slot of the lamp holder. Okay, a ballast troubleshooting. I want to see where we're going to end. So up to there, those are the basics of lamp. So next we are going to talk about the common faults in the discharge lamps. And this one is like a summary that we are going to go through. We have already gone through most of them. It is like a summary. And before we get into this, I would like people to unmute their mics and at least give a brief discussion, comments, so that we can proceed again. Unmute your mics of what we have been doing. So, with the common faults in discharge lamps, there are four main defective states of the lamp's appearance that are as follows. Number one, it's not starting. Number two is on and off cycling, extra bright light output, and low light output. You can see those are distinct features of these discharge lamps. So, as the fluorescent accessories, more so, the failure is relatively more than incandescent lamps. The common faults are as follows. When the power is connected, the fluorescent lamp does not light. So the failure reason is the lamp holder or the fluorescent tube starter or the starter seat is bad or has a bad contact, or the filament is broken, or the ballast coil circuit, or the new fluorescent lamp wiring error, or power is not connected. You see, if the problem is maybe there's a power is not connected, then you connect power. If it is a wrong lamp holder, then you replace with the right lamp holder. If the filament is broken, so you do the same. And then the lamp life is short or immediately after the light is off. So the failure causes, that is the ballast, with the specification that is inappropriate or poor quality. So ballast internal coil circuit short circuiting, resulting in the lamp voltage which is too high, and burnt filament by shock so that the filament is broken. So the new lamp, due to the wiring error, will light the tube turned out. So the fluorescent lamp flashing or only two headlight. So failure reason is the neon bulb within the dynamic or the static contact cannot be separated by the capacitor breakdown in short circuit. The ballast with the specification is inappropriate. So another thing is the light lamp is rolling and flashing lights. That is, the failure reason is a new temporary phenomenon. That is, the lamp quality is not good. The ballast with the specification is inappropriate or wiring loosening. That is, the starter is poor or contact or damaged. Another thing is the lamp ends black and raw black spots. Like maybe you can see black spots at the ends of the fluorescent tube. The reason can be that the lamp is outdated, meaning it has taken the lifespan is off. So the life will be the end of the phenomenon, such as the new lamp. So you have to place a new lamp. So in many, it may be due to the damage or to the starter filament emission material to accelerate the evaporation lamp conditions of mercury, and it is a common phenomenon, that is the power supply. So the ballast with noise, sometimes it is noisy or magnetic sound. Then the problem is the failure of the ballast. So there is a poor quality, or the core of the silicon steel sheet is not clamped, or maybe the ballast overload or its internal short circuit ballast overheating. So the electro voltage is too high and the starter is not good, so causing the open flow noise. So another thing is the ballast overheating or smoke, that is the false reason. Then the ballast internal coil must be short-circuited, or the power supply voltage is too high. Another thing is the lamp troubleshooting. Now we talked about troubleshooting in the other slide, and see that the fluorescent lamps, you energize and rapid start lamp, then low voltage transformer in the ballast provides cathode heating. At the same time, you are applying a higher voltage. So this voltage begins arc condition in the light. So take both voltage measurements in good indication, proper ballast condition. So those things conditions result from the following: that is, improper contact with the holder, broken holder, open contact, broken base pin, open cathode, shortened leads in the base, corrosion or foreign material on the base pin or holder contacts, and then defective ballast or improper wiring. Those are some of the things that are the problems. So heavy, premature, and darkening, we have talked about that. Lack of cathode heating, these are things that we have talked about. If the spacing is too tight, we said about that as well. So I think we have covered almost everything. So the metal halides lamp will drop in lumen percent. Those are now the efficiency, the working, the optimization of lighting if it is not working correctly. So ballast troubleshooting. Fluorescent ballast, it's difficult to measure the output voltage of the fluorescent ballast in the luminaire because of the primary circuit of the ballast is automatically disconnected when you remove the instant start lamp. So if you wire a replacement ballast to a fixture, make sure all the leads have a good electrical connection, especially if the lamp's holder have pressure lock. Then if the lamp in the fixture fail to light, then improper wiring could also be the cause. So sometimes you will find leads without the insulation. In some cases, you will find two wires using one slot. So check the ballast using the multimeter, similar to checking a fluorescent ballast. You should take specific safety precautions when working in the HPS ballast. Okay. There's a scobotropic effect. We learned about this thing some time back. This is normally in the fluorescent materials. That is, fluorescent materials with subjected to electromagnetic radiations of particular wavelength get excited, and in turn gives out radiation at some other wavelength. So this is the working principle behind the fluorescent lamp. So these lamps are widely used in homes and they have high efficiency and lifetime in almost 3 times of those filament lamps. So the strobotropic effect is a phenomenon which causes the running or more moving amount of equipment to appear stationary or appear to be operating slower than they actually are. So fluorescent lamps are provided with 50 Hz to 60 Hz AC current supply. So when operating under these frequencies, the lamp becomes zero, that is, crosses the zero wave, double the supply frequency. So 100 times for the 50 frequency and 120 times for the 60 Hz frequency per second. So due to this persistent of vision, our eyes do not notice those flickerings. However, if the light falls on the moving part due to illusion, they may appear to be either running slow or in reverse direction, or even appear stationary. So this effect is called the stroboscopic effect. The danger of the effect. Why is it danger? When a worker is in a factory, observes a running machine as a flywheel under the illumination of the fluorescent light, then the flywheel may appear to be stationary or to be operating at a reduced speed. So this can result in accidents and is highly dangerous. Sewing machine also, whose needle moves up and down, may appear to be stationary, and the operator can prick the fingers. So these are some these are some examples where the stroboscopic effect in the fluorescent lamp can prove to be dangerous. You can see that. So the effect is here. The method to avoid the effect is this pattern of illusion. Illusion is not allowed in industries, as this may lead to accidents. So this is the main reason why the fluorescent lamps are not preferred in industries. However, this effect can be avoided. You see, if you are insisting in using the fluorescent lamps in industries, you can avoid this by doing the following things. The industry is supplied with 3-phase supply, then adjacent lamps should be fed with different phases, so that the zero instant of the lamps will not be the same. And again, fluorescent lamps around the routing or moving machinery, 2 lamps powered by 2 different phases, should be used. So this ensures that both the lamps do not flicker due to the zero crossing of the same time. Another one is if single phase supply is only available, then the condition of the adjacent lamp are made just that the 2 lamps are connected in parallel with the supply, and in one lamp condition, a capacitor or a condenser is kept in series with the choke. So those are the ways that we can reduce the stroboscopic effect. And then the mercury vapor lamps and the troubleshooting, that is, was the first kind of metal vapor lamp light source that was mass produced by the general lighting applications. So still today, it remains one of the most popular discharge lamps produced globally. So in Europe, it has fallen out of fashion due to its relative inefficiency and rapid lumen depreciation, by contrast with other lighting sources. So however, it in the Americans or Asian countries, its low system cost, that is long life, and high temperature continue to make it a desirable and light source for the exterior illumination. So that is the construction of the high pressure mercury lamp, as most of the times you'll be told to draw the construction of that mercury vapor lamp and their working. So up to that point, we are